Okay. So this is actually chapter 11, slope deflection equation. There's certain thing I want to highlight. Okay, especially the concept, because the concept, as I mentioned, the concept of beam and frame, the concept, the and moment concept. Okay, because we both two methods, slope deflection method and moment distribution method, they we calculate member and moment, and some concept actually have been discussed in this chapter, especially okay, the the sign convention will be equal. We use clockwise, okay, clockwise positive. Yeah. Okay. This is one thing about the joint moment. About the joint moment. So member and moment ni, we focus on member. So if we look at this diagram, so I just want to explain the concept. So this is the diagram. Okay, this is the diagram. So there are two members. There are two members like this. So there are two members. Okay, two members. So two members means one member has two end. One member has two ends. So the 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 sign convention, the clockwise sign convention, we apply on member. So the clockwise direction. But we need to know that the joint moment which is located at B. So this is joint. This is joint B. The joint moment is actually opposite. Opposite with this. So the moment that we distribute, okay, is this moment. The moment that we distribute. Okay, not member and moment. Not member and moment. So you get this equal to, even though this is under slope deflection method, but the concept is same. You see, so this is actually joint B. This is joint B. Joint B. So actually this is the member. We have member. Okay. So the member and moment is clockwise. The member and moment. Okay, but the joint moment is opposite this member and moment. So and the moment that we distribute in the table is joint moment, not member and moment. So joint moment, so we can conclude that joint moment and member and moment, it is opposite between each other. So the opposite condition, that opposite condition is the reason why we change sign. We change sign whenever we want to distribute moment. So in the case when there is uh, an applied moment at, for example, at B, so then that one we don't have to change the moment direction. The moment that we change direction is only member and moment. Okay, so this is one thing that I want to highlight. This is inside the slope deflection equation, and one thing is this. Okay, this is the reason why another thing is okay. Okay, there is another thing is this. Okay, so MBA plus MBC because it is beam, right? Beam. So MB, this is because MB is equal to 0. We get this because of this. Okay, MB it is actually MB is equal to 0. So that is why MBA plus MBC is equal to 0. That is why in the table we always get MBA and MBC same value with different sign because we need to fulfill this condition. So in this beam, in this beam, MB, this MB is actually MB is equal to 0. Okay, so we have MBC here. This is MBA. This is MAB. This is MCB. So MBA plus MBC is equal to 0. So this is the concept that we apply the same in moment distribution method. So that is why in the table we get in the table for the column BA and BC, we will find that the value, okay, the two value is same but in opposite condition. Unless whenever we have find in the question something like this, then we will get MB, this is MB is equal to 30. Then only when we have MBA and MBC, then when we total MBA plus MBC, we get the this 30 kilonewton moment. So that is the concept that we apply the same in the table. Okay, so this is about the moment and the sign convention. Okay, there's one thing here. Okay, so for the diagram, so using slope detection method and moment distribution method, we get the same output, which is moment, member and moment or internal moment. Okay, in the structure, in the beam or in the frame. So this is all the member and moment. Okay, member and moment. So this member and moment, okay, this member and moment can be used to directly to draw Bending moment diagram. Bending moment diagram. But if you want to analyze the shear force, draw shear force diagram, or if you want to analyze the reaction, the vertical reaction at the support, we need to apply static equilibrium. We need to apply static equilibrium means that we have to know that the free body diagram, okay, the free body diagram is like this. So this is joint, this is member. Okay, we focus on member only. Okay, there is a loading. This Okay, so we get from this 1.54, here is positive 1.54, then positive, we get 3.09, 3.09, and then we get negative 3.09, and 12, this is 12.86. So actually, to complete this diagram, we also have the vertical force, vertical reaction, vertical reaction. And we do not know the value yet, so we can analyze this using static equilibrium. It's just like we analyze simply supported beam. Okay, so we call this as A or VA. This is VB1, VB2. Total VB1 for VB2, then we get VB or BY. So this is BC. So using static equilibrium, actually we can calculate the VA and VB value using static equilibrium. Static equilibrium means we just need to analyze this like we analyze simply supported beam. Simply supported beam. Then we will get VA and VB. And then we do the same for VB2 and VC. So this is 6. So this is how actually, okay, this value AY, BY, okay, is actually calculated. Then only we can draw the shear force, this shear force diagram. Shear force diagram. So from shear force diagram, actually we can get, if there is intersection, means that there is a maximum moment. So we get this value, from shear force diagram. This is from shear force diagram. So, the value here, 1.54, 3.09, and 12.86 is actually the value that we get, okay, this, okay, from member and moment. Means that from member and moment that we get from table, from distribution table, we can get the diagram, the BMD. So this is BMD, this is BMD. But if you want to determine the maximum moment, this is maximum moment in the bending moment diagram. Okay, we can get from shear force diagram. And to calculate the way to draw the shear force diagram, we need to analyze this and this. Okay, using static equilibrium. So we actually do the same for moment distribution method. Okay, so we move to next concept. So I just want to highlight the concept. If you want to ask anything about the concept, so you may ask right now. Okay, now I want to move to frame concept explain in, okay, in chapter 11. Analysis of frame, no sides way. Okay, there are two reasons as I mentioned in my video. So for no sides way frame, okay, for no sides way frame, then no sides way frame, there are two conditions. Okay, a frame will not side sway. A frame will not side sway. Okay, side sway means, okay, not side sway means displaced, not no movement. Okay, no horizontal. Side sway means side sway. Side sway means horizontal. Horizontal displacement. Side sway means horizontal movement. This is side sway meaning horizontal movement. Okay, side sway means horizontal displacement, horizontal movement. Displacement. Okay, provided it is properly restrained. Okay, properly restrained. So properly restrained. Properly restrained. Okay, what is the meaning of properly restrained? No such way will occur in unrestrained frame. Okay, another reason is symmetry. Another one is symmetry. Symmetry. Okay, so let's look at this. Okay, so yang ni is under category number 1, properly restrained. Properly restrained. Because properly restrained ni maksud dia ada satu restraining force, where it come with support. So ni restraining force. R ni will exist whenever there is a support. Any support doesn't matter as long as it is, okay, we only look at the horizontal reaction. Okay, comes with support. Okay, it can be fixed, it can be pinned. Okay, it can be fixed, it can be pinned. Like this. So P ni, if frame ni kalau dia roller kat sini, with this loading, it can move. This roller can move horizontally. Okay, this is not restrained. This is not restrained. But if this is fixed or pin, okay, it comes with horizontal, it comes with support. Okay, then it is called as properly restrained. So same goes to the second diagram. So diagram number 1 is not symmetry. Diagram number 2 also is not symmetry. But when it is not symmetry, we have to look at the support. Okay, if it is fixed, if it is pinned, means that there will be a horizontal reaction. Now with support, the horizontal reaction is called as R. So this R means restraining force. Restraining force. Okay, so this is the meaning of properly restrained. Okay, so look at the diagram in figure 11.15. Okay, in this diagram, by looking at the diagram is symmetry due to loading. This is loading as well as geometry. So means all this is called as symmetry. Okay, symmetry under reason number 2. Symmetry, no such way will occur. No such way will occur. No such way means no delta. Okay, no such way means no delta. Okay, no such way means no delta. So when there is no delta, so we will only calculate FEM Because FEM there are two FEM due to loading and due to delta. No delta means delta is equal to 0. No delta means this one delta is equal to 0. So we don't need to calculate FEM due to delta. So we focus on loading only. So this is for no such frame. So this is symmetry. Okay, symmetry frame. Okay, another one. Okay, this one. This one is, okay, is it symmetry? This is not symmetry. This is not symmetry. But is there a restraining force here? Yes. Because of this pin, there is a restraining force. When it has restraining force, it becomes properly restrained. Properly restrained. When properly restrained means delta is equal to 0. Okay, when delta is equal to 0, so FEM, okay, we only consider loading. Okay, loading only. So with that we can solve. Okay, if this question we want to solve using moment distribution method, so we can solve using one table only. Okay, so this is again the join. Okay, the join. As I mentioned, we have to understand two things, which is called as join, moment, and member and moment. We need to understand these two things. Number one, number two, two things. Okay, the output in moment distribution method is this one. This is MDM output. This is what we want to calculate, member and moment. So how we want to calculate member and moment? We calculate member and moment using join moment. Okay, how to calculate it? How to calculate the join moment? Okay, we calculate member and moment. Okay, this member and moment we calculate using join moment times distribution factor. And what's the difference in terms of the sign convention? What the difference between member and moment and join moment? Between these two, 1 and 2, the sign convention is opposite, with opposite between each other. Opposite between each other. Sign convention for this case, for this one, sign convention opposite. Okay, sign convention is opposite. So that is why in the table we need to put, okay, we need to change sign whenever we want to distribute moment. When we distribute using join moment, where join moment is opposite with where direction of end moment and join moment is opposite between each other. Okay, so sign convention that we apply in the method, in this method, is actually referring to member and moment. So that clockwise moment, clockwise positively, we apply this, okay, for the output. The first sign convention that we apply. Of course, when we calculate the moment, we will get negative or negative depending on the loading. But we assume that in the first, okay, in the first, we need to apply clockwise moment, okay, at on each member. Then by calculation, we will get whether it is negative or positive. But the first assumption that we made is clockwise moment. It is clockwise for member and moment. It is clockwise for member and moment. Okay, in the beginning of analysis. the assumption. Okay, that is why if we see this, this is actually referring to join. This is join. This is also join. So the moment is opposite with clockwise. It is anti-clockwise or counter-clockwise. Okay, so this is side wave frame analysis. Okay, the concept of side wave frame analysis is, because as I mentioned, FEM we have to consider two, not only loading. FEM we have to consider two. One is loading. Number two is delta. Okay, and delta is equal to 0 when there is no side wave. When there is no side wave. But if we have like this frame, when P, this P is subjected not at the center, not at center. Means that this is not symmetry anymore. This is not symmetry anymore. Loading is not symmetry. When loading is not symmetry and there is no restraining force, we don't find any restraining force. We don't find any support at B or at C. So no restraining force means no means okay. No restraining force means it is not, it is improperly restrained. Which restraining force, the frame will be properly restrained. So in this case, we have two. Okay, we have to consider FEM due to loading, and the second one FEM due to delta. So this is the concept we apply in moment distribution method. So the concept, okay, the concept about this, okay, is explained under two topics. Number one is slope detection method. Number two is moment distribution method. And this theory or this principle, okay, you can find in chapter 11, not in chapter 12, because the concept is not repeat. Okay, again, okay, again, this is frame besides way as well. So in this frame, we can find that this frame is not symmetry, of course, due to loading is not symmetry, and geometry is also not symmetry, because this is 12, this is 18. So this is side wave frame. This is side wave frame. So but in this case, because loading, okay, because FEM for loading, FEM we calculate for member on the for loading on the member. So in this case, there's no loading subjected on member. Means that in this case P is equal to 0. So means that in this case, if we want to analyze using moment distribution method, we will only get the value which is come from delta. Okay, so this is about the side wave frame. And again, this is for joint D. Okay, the joint moment opposite with member and moment. Member like this. Member like this. And the joint moment, this is joint moment, this is joint moment opposite with member and moment. So we distribute joint moment. We distribute joint moment. You see? So this is member. So the moment is clockwise. Clockwise. Okay. This is member and moment. Okay. So now we move to chapter 12. Actually, chapter 12 about the concept of frame with side sway, I have actually explained in the video I have told you just now. I have prepared that video last 2 days. Okay. Okay, I have explained this in the video. So this is actually the example, but use empirical unit. Okay, this is actually the frame with inclined member. So this is also under MDM coverage. Okay, let's see if there any question that we can do it right now. Okay, if not, we find in the past year's exam paper. Past year's exam papers. Okay, this question we can analyze using MDM. This question, even though this is the flexibility method question, this one we can actually solve using moment distribution method. So A is fixed, D is spin. So we will analyze this using a moment distribution method. This is side sway frame. This is side sway frame due to loading, because loading is come from left side, so the frame will tend to side sway to right direction. Okay, the frame will tend to sway to right direction. Okay, right direction. Okay, with that D will move to new position. C also will move to new position. So means that in this diagram we have, okay, we use principle of superposition. Principle of superposition. So this diagram, okay, in this diagram, W plus delta. We have W plus delta. W is loading, we have delta. But delta is unknown. So delta is unknown. So we need to calculate, we need to analyze this frame, okay, using two tables. One is to calculate FEM due to W, and then we will calculate FEM due to side sway, So there are two tables. Okay, so by applying the principle of superposition, so we know that this beam will tend to side sway to right direction, so we put an imaginary support, an artificial support at C. So that will bring us the restraining force, which come from from okay at C. Okay, the frame is tend to sway to right direction, so we have to put the restraining force at C. So we get this. Okay. This one. Okay, so loading is remain lah. Loading is remain. We want to remove delta from, okay, we want to remove delta because we want to analyze, okay, this is the loading. Okay, this is the loading. So we need to put an imaginary support. So we put pin here. Roller also can, but we put in horizontal direction. Because what we want is the restraining force. Okay, this is the restraining force. Okay, so this restraining force is just like we put the wall so that it cannot move. So C cannot move, so B also cannot move. So by having this, we have changed, okay, the original frame to properly restrain. The original frame is like to frame. We change to properly restrained frame by putting an imaginary support pin. So with that support, we have actually put the restraining force in that direction so that the frame cannot move to right direction. Okay, so this is the support. The support. Okay, from fixed support we get here is this is fixed, this is pin. Okay, so okay, this one is actually lens wave frame, and we can analyze this member and moment in this frame using moment distribution table directly, because we know the value of W. We know the value of W. But okay, this equation, this principle is principle of superposition is not completed yet, because this one is not equal to this until we add another diagram. Okay, because we need to neutralize the R. So we need to neutralize the R, so we have to add another frame. We have to add another frame. Okay. Another frame like this. So here we have to put R but in opposite direction. R in opposite direction. So this is in opposite direction. Okay. So this is pin, fix, and pin. Pin. Okay. So after we have plus with this, then only we fulfill the principle of superposition. Principle of superposition, because due to R, we have the delta. We have the delta. And for frame, the delta is horizontal, because side sway referring to horizontal movement. Side sway referring to horizontal movement. Okay, side sway referring to horizontal movement. And the delta will appear at D and at C. And we assume that the delta at D and at C equal. Okay, this is for C. Okay, the delta. Okay. Okay, so this is actually the delta. This is the delta. The delta are same. Okay, so you get the idea. So we have W, we have here. Wait, let's do this. Okay, we have W plus delta. We have W plus delta in the main diagram. W plus delta in the main diagram. So we have to divide this into two diagrams. We want frame with only W and we want frame with only delta. So how to do this? Okay, we will actually divide this into two diagrams by using the principle of superposition. By using the principle of superposition. Okay, so diagram number one, this is the frame, okay, with only W, because we have made this as properly restrained frame. So this one is now properly restrained frame because we have bring the restraining force with an artificial support that we put at C. Okay, so with this condition, now this frame is only have W. Okay, W. And in order to fulfill the principle of superposition, we have to neutralize the R. Okay, so we have another frame which is only delta. Okay, which is delta. We have this is the delta. Okay, we have another frame without W but only has delta. Okay, this delta comes with R, the restraining force, R. Okay, and the frame is tend to sway to the right direction. So this is the idea about principle of superposition. Okay, so the first table, the first distribution table will be focused on, okay, let me put the label. If this is diagram A, this is diagram B, this is diagram C. So the moment distribution table, the first table will be diagram B. Okay, we can calculate the end moment. Okay, okay. So now, nampak pencil sekejap. Ini, okay. So table number one in moment distribution method frame with such way is actually we analyzing diagram B. So how to analyze this? So we have distribution table. So in the table we have member. Okay, we have to calculate K. Okay, in terms of EI. And then from K we calculate distribution factor. And after that we start with the first distribution. And then the next step after that is carry over. We repeat the process. Basically, 5 or 6 times cycle carry over distribution. 1, 2, 3, 4, 5, okay, 6. Okay, we have AB, we have BA. So we have 3 members, so we have 6. We have 6 member and moment because one member has 2 and moment. So we have 3 members, we have 6. AB, BA, so we have BC and CB. Okay, NC for member BC is CB. Okay, NC for member CD is CD. And then we have BC. So there are 6. A, AB, BA, BC, CB, CD, DC. Okay, K, so it is 7 meter, it is 4 EI over L. It is 4 times 2 divided by 7. Okay, it is 4 times 2 because it is 2 EI. Okay, divided by L, L is 7. So it is equal because this is actually the same value. Okay, for member PC, it is 5 meter. 5 meter EI, so it is 4 divided by 5. So this is the same. And for CD, we use 3 EI because it is pin, yeah, pin. So we have to use 3 EI. It is 3 times 2 divided by 7. This is how we calculate the stiffness factor easily using Excel. So for AB, this is A is fixed, so it is 0. D is pin, it is 1. So then we calculate as usual. So this is total this plus this. Okay, KB plus KBC. So this is 0.588. And actually we can find the distribution factor for CB using simple formula 1 minus this. Okay. And for CB, it is 0.8 divided by this one plus this one is KBC plus KCB. Okay, so we get 0.482, 483, 483. So it is 1 minus 0.483. So we already calculated. Okay, this DF. Okay, so now we move to, oh sorry, there is one thing miss here, is FEM. FEM is actually the first member and moment in the table. So we will get member and moment from AB only. From AB only. So okay, we refer to the formula. So the formula is okay, this one. So we have W L of square over 30 here. This is 20. This is WL square over 20. This is WL square over 30. So means that we have here AB AB Okay, so this is W L squared over 30. This is W L squared over 20. This is 7 meter, and the value is 750. 750. 750. This is 750. So if it is 750, then this 750 WL squared over 30. W is 750. W is 750 times L is 7 square over 30. So it is 122. It is 1225. 1225. Okay, another one, it is 750 times with 7 square divided by 20 by 20. This is 1837.5. 1837.5. So for FEM, it is negative 1225 and 1837.5. 1837.5. 1837.5. So we start the first distribution. Okay, so join B. This is join B. Okay, join B. Join B. So the join moment is okay. Join B. It is look like this. Okay, it is look like this. Okay, it look like this. So this is join B. Okay, the moment that we calculate from fifth end moment is 1837.5. Here, there's no value. There's no value. Okay, the concept is like this. There's no value. So the moment that we distribute is this. It is 1837.5. Okay, the value that we use to distribute or to time with distribution factor is negative value, not the positive value, because we distribute the joint moment. So that is why we put negative. Negative. Total moment means this one plus this times with distribution factor. Distribution factor. Okay, it is 1 negative 1080.882. So we do the same for BC. It is this plus this. Okay, plus KE27 times with distribution factor. Okay, and total this four value must equal to 0. The total value must equal to 0. Okay, total value must equal to 0. Okay, then there's no value to distribute for joint C and joint D. So we continue with the next step, which is carry over. We time with carry over factor, it is 0.5. So this value divided by 2, and this value also we divide by 2. Okay, so we get this and this. Okay, we carry the value to the opposite joint. So then we repeat the process again. Okay, we repeat the process again. Then at B, there's no moment. Now the moment, okay, is now moved to C. So we have to calculate distribution. Okay, the moment at C. Okay, it is negative for opposite condition of joint moment. This one plus, okay, concept we have to plus this two. Okay, and times with the factor. With the factor, this is the factor. Okay, and for CD, times with distribution factor. Okay, so this four value will equal to 0. Okay, 0. Okay, now we have to carry over the value. So this one we carry over the value. Okay, the factor is 0.5 for internal support. So it is 182.632 divided by 2. But here the value is 0 because the factor for n pin is 0. So there's no value to distribute here. Okay, so then we have to repeat again the process. We repeat the process. We distribute the value. Okay, so actually I have set the formula, so that is what I just copy here and paste. Okay, so total of this equal to 0. Okay, it is actually total moment. Okay, total moment. So means that for this level, the concept is like this. Okay, we have joint. Okay, at joint B, we have this moment 91.316, and there's no moment from the other side. And this 91.316, before we distribute, we have to know that we distribute which is opposite. Okay, opposite one, because we distribute the joint moment. So the moment that we distribute is the pink one, 91.316 plus 0 here. So that is why the value that we get after we times this two factor, we get negative. Okay, we get negative. So that's the concept that we need to know. We always distribute joint moment, not member and moment. Okay, so we get this. So again, we repeat the process. This one divide by 2. This one also we divide by 2. We have this factor and we apply the opposite join. Okay, and then repeat again the process. This one I just need to copy the formula. And then I get the value. And make sure to check the value whether this is 0 or not. Okay. Okay. Okay, it is total moment at join times this factor, so we get this. Okay, then we have to carry again this divided by 2, and this one becomes 0. Okay, repeat again the process. Okay, I copy this formula, paste here. Okay, and then I carry the value, divided by 2 for n fixed and internal support. And fixed and internal supports. Okay, then look like we still need to continue the process because it is near far from 0, so we have to do this until we reach 0.0 something. This is still 1. Okay, so we continue, copy this, yes, okay, and carry the value, this one 0. This is carry over. Remember to stop at distribution, not carry over. So for this one, I will copy this formula. Can you listen to me? Continue. Okay, we have to repeat the process again and again. So this is how we calculate using Excel. So now we reach 0.0 something here. So we can choose to stop. And then we just need to total the moment. Okay. So here is the moment. Okay, this is actually the moment from table 1. The moment from table 1. You can see that, okay, this is the end moment actually. So the last value is 0. The last value is 0 because it is pin. This is pin support. So total MCA plus, sorry, MCB plus MCD. Total is 0. This is MVA plus MVC. Total is 0, 1 negative, 1 positive, and moment at A is equal to this. Okay, this is only for table number 1. Table number 1. Okay, So do you have any question regarding this? So okay, I will continue to analyze table number 2, frame, the side square frame FEM due to delta, which will be made from assumption of FEM value, because we don't need to calculate the delta value, but we have to make assumption for some reason. We will actually introduce frame and a new frame, okay, which is subjected to R prime value, and we will assume the FEM value, and lastly we will uh, calculate the M value, okay, in M value in diagram C using interpolation. Okay, so I have explained this principle, this method in my previous video. Ada dalam YouTube, so you boleh tengok. Tapi this question saya akan completekan evening, this evening. So I will compile this video. So for series number 1 and series number 2. Okay, so this is very very important, frame research way, and this is actually the basic thing that you need to understand to know for frame research way. So actually frame research way, we have another two two types that you need to know as well, which is column, one column incline or two column incline. But this is the basic that you need to know lah. Okay, so continue to actually search relevant video or notes that can help you to understand about peak and moment. Okay, so that's all for this session. We will continue. I will continue this in the evening slot. So and then I will compile and put the link in the YouTube channel as usual. Okay, so that's all for this session. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you.